Hello, dear students. Good evening to each and everyone. I all of you welcome back to the Wallah English channel. And in this series, we are studying signals and system in very much comprehensive manner. Already we completed first chapter, and today I will finish second chapter also. From next class, we will start the continuous time Fourier series. Okay. So first of all, tell me, am I audible properly? Audio and video both are clear to you people? Okay, so shall we start, guys? Properties of an LTI system. This is part 2, and today we will finish all the properties of an LTI system, and then we will solve some important questions based on the all the concepts of second chapter. So next, first we have seen under what condition an LTI system is said to be causal and static. So we have seen if any system can be represented by in its impulse response, guys. Okay, whether it is discrete time or continuous time, it can be represented in its impulse response. Okay, so h of t, if it is a continuous time system, then h of t is nothing but impulse response. Okay, and for discrete time system, h of n is impulse response. Okay, so first is causal. Okay, continuous time, causal, guys. So for the continuous time, impulse response h of t is less than 0 for t less than 0. So if for t less than 0, if the impulse response okay, now audible, guys? Audible now? Okay, so let us start. Let us start, guys. Okay, so here now for the system to be causal, h of t is equal to 0 for t less than 0, and if it is a discrete time system, guys, for the discrete time system, impulse response h of n is 0 for n less than 0, correct? And a system is said to be static only if it is a continuous time system, if impulse response is a impulse function itself. Impulse response is a impulse function itself. Okay, so here h of n is equal to k del n, correct? K into del n, fine. So in this case only a system is said to be causal and static. Otherwise, if it is not satisfying this condition, then the given LTI system is said to be non-causal. And if LTI system is not satisfying this condition, these two conditions, that is said to be dynamic system. Okay. Now next is stability, guys. Under what condition the LTI and LTI system is said to be stable? Okay. Now we know that for the stability, LTI system should produces bounded output for the bounded input, or we can say if an LTI system produces bounded output for the given bounded input, then it is said to be stable, guys. This is linear time invariant system, and this system is represented by its impulse response. Okay, so x of t, this is y of t. Okay, now see here, an LTI system is said to be stable if for the bounded input, already we have seen in the first chapter, for the given bounded input, output should be bounded. For any finite input signal, output should be bounded, guys. Bounded output for the given bounded input. Okay, for the given bounded input, output should be bounded, guys. Okay, now bounded input means what? What is a bounded input? So mod x of t, magnitude of the x of t should be less than or equal to mx. Okay, this is the magnitude. Any finite magnitude which is less than infinite, and for this bounded input, output should be also bounded like this. Mod y of t should be less than equal to magnitude of y less than infinite. In short, magnitude of output signal y of t should be less than infinite for the bounded signal, guys. Okay, so here for system to be stable, here I'm writing for an LTI system, to be stable, mod y of t should be less than infinite. Now we know that what is the mod y of t, guys? It is nothing but y of t is nothing but integration minus infinite to plus infinite, x of h of tau into x of t minus tau d tau should be less than infinite. Okay, magnitude, guys, magnitude should be less than infinite. Now we know that this is what bounded, guys. Input is bounded, this is input, and this is the bounded input, guys. Okay, so this is finite. Okay, this term is finite, guys. Any finite value less than infinite, correct? Okay, so this term should be finite, guys. Overall this term should be finite. Now this is already bounded, so this is possible only when this magnitude, guys, absolutely integrable. here, as this is the bounded input, so it can goes out opposite side. Okay, so it is infinite. Infinite but finite is nothing but again infinite. So here it should be h of tau d tau should be less than infinite. Okay, instead of tau you can write t, guys. You can write t also. So for an LTI system to be stable, its impulse response should be absolutely integrable, guys. Mod, you are taking mod then integration, it is meaning is what? Absolutely integrable. So here we can say impulse response should be absolutely integrable. If response if the impulse response is absolutely integrable then we can say it is a stable system. If the impulse response is absolutely integrable for the continuous time, and for the discrete time, if the impulse response is absolutely summable. For the continuous time, if the impulse response is absolutely integrable, and for the discrete time, if the impulse response is absolutely summable, then we can say the given LTI system is said to be stable, guys. Okay, so here if it is a continuous time system, again I am writing, if it is a continuous time system, then if its a impulse response is absolutely integrable, then it is stable system. Then it is stable system, correct? And for the discrete time system, guys, the impulse response should be absolutely summable, guys. Instead of integration, now discrete time. So that's why it is minus infinite to plus infinite. It should be less than infinite. So in this case, the discrete time system is said to be stable system, correct? Okay, very good. Fine. Clear to each and everyone? Now next, guys. Next property is what? Invertibility. Under what condition? Under what condition an LTI system is said to be invertible, guys? Okay. So invertible system. If system is invertible, then its inverse system also exists, guys. Correct? If system is invertible, then its inverse system also exists. Suppose this is an LTI system. Okay, LTI system whose impulse response is h of t, and if it is invertible, input is x of t, and for this input it is producing output y of t. And let us consider, if it is invertible, then if you give output of this system to its inverse system, if you provide output of this system to its inverse system, then this output of its inverse system is x of t only. What I'm saying, suppose h of t is an this is one LTI system, and let us consider its inverse system also exists. Then if you provide output of this system to its inverse system, and let us consider the impulse response of an inverse system is h I n v of t. Say for example, just notation. Okay, this is what impulse response of an its inverse system. And if you provide output of first system to its inverse system, then the output of its inverse system is nothing but x of t only, if it is an invertible system. If this is an invertible system, then if you provide output of this system to its inverse system, then then output of its inverse system is nothing but this input x of t. Then and then we can say it is an invertible system. Okay, Fine. Now here y of t, guys, y of t is equal to x of t, y of t is equal to x of t convolution with x of t convolution with h of t, correct? Output of first system. And z of t is equal to z of t is equal to y of t convolution with inverse impulse response of inverse system. Now put value of y of t from here to here. So z of t is equal to x of t convolution with h of t, x of t convolution h of t convolution with h inverse of t. Now if this z of t is equal to x of t, then and then we can say h of t is an invertible system and its inverse system is this one. So here I am writing if h of t, and it is possible only when h of t convolution with its inverse system impulse response is del t. Suppose if this is del t, then x of t convolution with del t is equal to x of t. Each h of t, if h of t convolution with its inverse system, and if it is an impulse, if it is an impulse function, then what will happen? Then z of t is equal to x of t convolution with del t, which is equal to x of t only. And an LTI system, an LTI system is said to be invertible. Otherwise it is non-invertible system. So condition is what? The convolution of h of t and its inverse system should be impulse function. If it is an impulse function, then we can say invertible system, otherwise non-invertible system. Clear? Nikhil, tell me, is this clear to you? Fine. So what we can write here, in the same way, this is a condition, guys. In the same way we can write for the discrete time system also. This is the condition for the continuous time. See, we got the condition for the continuous time. If it is continuous time system, it is invertible only. Convolution of h of t with its inverse system impulse response, h inverse of t. If it is del t, then and then it is an invertible. And the same thing is applicable for the discrete time also. H of n convolution with impulse response of its inverse system is del n. In this case only, it is said to be invertible system. In this case only, it is said to be invertible system, guys. Fine. Clear? Is this clear? Okay. Now summary of all these property: causality, static, stable and invertible. Let us make the summary. Summary table. So here property for the continuous time and for the discrete time, guys. Correct? Okay, let us prepare the summary table. Total 4 properties, correct? So here I'm writing different properties. Different properties for the continuous time, and here I'm writing for the discrete time. Okay. So first property is causality. So for the causality, guys, impulse response here, impulse response h of t is 0 for t less than 0, and here impulse response h of n is 0 for n less than 0. Correct? Now next is static, guys. Static. For an LTI system to be static, if its impulse response is impulse function itself, k del t, and here same thing, h of n is equal to k into del n. Fine. And next is, just today we have seen stability, guys. Stability. An LTI system is said to be stable if its impulse response is absolutely integrable. If you take modulus and then integration, and it is known as absolutely integrable, guys. Name is what? Absolutely integrable. Okay, if the impulse response is absolutely integrable, then and then the given LTI system is said to be stable, and here absolutely summable, guys. N is from minus infinite to plus infinite mod h of n less than infinite. Okay, and last one is invertibility. Okay, so an LTI system is said to be invertible only when a convolution of h of t with its inverse system impulse response, if it is del t only. And here same thing, h of n convolution with its inverse system impulse response is del n. Fine. Okay, so they can ask in multiple select question also. One student is asking what is the weightage of this subject. So if I'm talking about weightage, so in GATE exam for electronics it is 8 to 10 marks, and for electrical students it is something around 5 to 8 marks. Okay, or we can say 4 to 7 marks for electrical. And instrumentation again 7 to 9 marks weightage. Okay, so this is all about summary of properties of an LTI system. So all the topics we completed in the second chapter. Now we will solve some question based on all the concepts. Okay, so let us start with very first question. This is the question: a continuous time linear system, see, linear system with input x of t and output y of t yield the following input output pairs. They are saying one LTI system is there. If this is the input, it produces this output. If this is the input, and for this input produces this output. Now they are saying if x1 of t is this input, then what is the output corresponding to this input? Okay, so y1 of t is the output corresponding to this input. So that you have to find. So tell me which option is the correct answer. This is the linear system, so you can use here property of linearity. Tell me which option should be correct answer for this question. Which option should be right answer? Okay, so how to solve this question, guys? See here. So this is the input. For this input, it produces this output. For this input, it produces this output. Now, what is the input? X1 of t is cos 2t minus 1. Now use the Euler form, guys. E power j theta plus e power minus j theta divided by 2. So e to the power j 2t minus 1 plus e to the power minus j 2t minus 1 whole divided by 2, guys. So x1 of t is equal to 1 by 2 e to the power minus j e to the power j2t plus 1 by 2 e to the power j into e to the power minus j2t. Okay, and for this I am finding output y1 of t, guys. Correct? Y1 of t. Now here we will use the property of linearity. Okay, so see, now if this is the input, guys, e power j2t, then this is the output. So here for this input, output is what? E to the power, if this is the input, e power j2t, output is e power j5t. Now as this is a linear system, so linear system satisfies the principle of homogeneity and superposition theorem. Correct? So homogeneity theorem says that if this input is multiplied with any constant k, then output also multiplied with same constant. E power minus j is a pi, e power j what? Cos j minus sin j. Correct? Cos 1 minus j sin 1. Correct? So it is a constant value in short. So 1 by 2 e power minus j any constant value. So if this input is multiplied with any constant value, and as this is a linear system, so output should be multiplied with the same constant. Similarly here for this input, what is the output? If input is e power minus j2t, output is e power minus j5t. So e power minus j5t output for this input. Now again same thing, if it is input is multiplied with 1 by 2 e power j, output should be multiplied with the same constant because this is linear. Now if you are adding two input, so individual response also you can add, guys. For this input, output is this. For this input, output is this. And if you add the individual input, you can add the individual response also, output also, guys, to find the total response. Correct? So this should be output, guys. So here addition means superposition theorem and multiplying constant with means homogeneity theorem. Both we can use because this is a linear system. Now you can convert this into the cos. So y1 of t is equal to 1 by 2 e power j theta plus 1 by 2 e power minus j theta. So it will be cos theta is what? 5t j you can take common, so 5t minus 1 is your theta. So this is the output. Correct? This should be output, guys. Fine, this should be output of this question. So which option is the right answer? So here cos 5t minus 1, option A. Option A is the correct answer for this question. Fine, very good. Option A, first option is the right answer. Very good, guys. Clear? So this is the answer of first question. Now similar way, let us solve the next question. This is also a very good question, guys. So tell me, solve this question and tell me what should be the correct answer for this question, guys. Which option is the correct answer here? Now here, suppose x of t is given, this one, it is 1 between 0 and 1, rectangle pulse between 0 and 1, h of t, x of t by a, where a is less than or equal to 1. See, if a less than or equal to 1, so suppose if a equal to 1, then x of t and h of t remains same, guys. Both are same if a equal to 1. And if a less than 1, guys, suppose a equal to 1 by 2. Suppose a equal to 1 by 2, then it will be x of a equal to 1 by 2t, guys. So here compression will occurs, correct? If a equal to 1, then x of t which is equal to h of t. And suppose if a less than 1, then convolution of x of t, h of t will result in the this will be what? Compression operation. So here, see, first of all, draw x of t, guys. See the solution here. First of all, draw x of t. So here I am drawing x of t. It is 1 between it is 1 between 0 and 1, guys, correct? And here I told you h of t is nothing but what? Compressed version of x of t with the scaling factor a. With the scaling factor a, guys. So if you draw the h of t, see, if here width is 1, guys, here what is the width? So width of this signal is 1, then of course here compression occurs. So width of h of t will be less than x of t. Compression, guys, compression by the factor a, correct? Compression by the factor a, guys. This is 0, okay, and it should be 1 upon a compression, guys, or we can say a, guys. See, mathematically I am writing, see, x of t is, it is 1 between 0 and 1. Now x of t by a, so it will be 1. Now t become t by a, so here also everywhere t upon t become t by a, guys. T become t by a, here also t become t by a. So this h of t, which is nothing but x of t upon a, which is 1 between 0 less than or equal to t less than or equal to a. So it is 1, it is amplitude 1. This is 1, amplitude 1 between 0 and a, but make sure this a is less than or equal to 1. This a is either 1 or less than 1, guys. So of course due to compression width is decreased. Now here width is a, guys, okay. So here convolution of two rectangle pulse with unequal length is nothing but trapezoidal function. So here I am drawing the resultant signal, trapezoidal function, correct? The resultant signal will be trapezoidal. The resultant signal is trapezoidal. What about the lower limit? So lower limit is sum of lower limit of x of t and h of t, guys, correct? This is h of t. So 0 here, lower limit 0. So here also lower limit is 0, guys. What about upper limit? Upper limit is 1 here. Here upper limit is 1. So here it is 1 plus a, guys, correct? 1 plus a. Okay, this is 0. Now this is y of t, guys. So option elimination method. This is the resultant signal y of t. So here option C eliminated, option D eliminated. Now option A and B, what is the difference? Here upper limit is 1 upon a and here upper limit is 1. So which option is the right answer? Here lower limit 0, upper limit 1 plus a, upper limit is 1 plus a. That's why we can say option A, guys. Option A is the correct answer. Option A is the right answer. Now what about these 2 points, guys? Already I told you guys, lower plus upper, upper plus lower. So lower plus upper, it is A, and upper plus lower, it is 1, guys. But we know that A less than or equal to 1, less than 1. So if A less than 1, so this is 1 and this should be A, guys. Correct? So you can see here, this is A, this is 1 and this is 0. Option A. So in this way, we can solve this question. Option A is the right answer. Correct? Option A is the correct answer for this question. Is this clear to each and everyone? Fine. And if I'm talking about the amplitude, amplitude also we can find. This amplitude is nothing but what? Width of first signal, amplitude of first signal into amplitude of second signal multiply with minimum width of x of t and h of t. So amplitude 1, 1 into 1, 1, and minimum width is A, guys. Here, because here width is 1 and this is A and A less than 1. So this amplitude is A, guys. Correct? This amplitude will be A. 1 into minimum width of x of t and h of t. So this amplitude should be A. Fine. Okay. Now here we can see if A is equal to 1, guys. If A is equal to 1, then we can get answer C also, guys. So here C also possible if A is equal to 1, because they are writing less than or equal to 1. This is the case when A less than 1. So option C also possible. So many students will get the wrong answer. They can get the wrong answer. See, if A is equal to 1, suppose put A equal to 1 here. If you put A equal to 1, then width of both the signals will remain same, guys, will be same. And the convolution of equal length pulse will result in the triangular function. So here option C also possible. Here option C also possible when A is equal to 1. So both A and C are correct here because they are writing A less than or equal to 1. So if it is less than 1, then option A is correct. And if A equal to 1, here in this option also you can see, if A equal to 1, then this point and this point will be same, this point and this point, and this will be 1 plus A, guys, that is same. So here option C also possible, but let me check once. Yes, option C also possible, guys. Correct? Option C also possible here. Clear? Are you getting? So B is absolutely wrong answer here. B is absolutely wrong answer. Here option C is the correct answer. Option A and C both are right. Fine. Okay, if you have any doubt, then you can ask. Now next question, guys. Now try this question. Now try this question and tell me the correct answer of this question. The graph of, this is very much easy question, guys. Which option is the correct answer here? Sinchan Reddy is saying option B should be right answer. Okay, so let us solve this question. It is quite easy question. So g of t is equal to rectangular function 4t. Now before applying any property of impulse function, first apply this scaling property. Before applying any property of impulse function, whether it is product property or sampling property or shifting property or convolution property, first you have to use the scaling property if there is a scaling factor. So here scaling factor is 2, so we know that it is 4 by 2 into del t. Correct? Scaling property. Del alpha t is equal to 1 upon mod alpha del t. So here g of t will be, it is 2 rect this 2 rect 4t convolution with del t. So convolution of impulse with any function is nothing but that function itself. So here 2 rect 4t. Now compare it with the standard format. So standard format is a rect t by t upon capital T. So from here you will get the amplitude A equal to 2 and total width is 1 by 4 guys. So observe which option is the right answer. So here amplitude is 2 guys, amplitude is 4, option B wrong, amplitude is 4, option C wrong. Now here total width is 1 by 4, so that's why option A. Here total width is 1 by 2, here total width is 1 by 2, so this is wrong answer. That's why option A is the correct answer. Option A. Which college can I get in? 55 number in GATE. So it depends on your branch, ECE electrical instrumentation. Is this clear guys? So option A should be correct answer. Option A should be right answer for this question. Fine. Not C, option A. This is the convolution property, not the product property. Okay, convolution property. Okay, now next question number 4 guys. This is also very good question guys. Very good question. X of t convolution with h of t. An impulse response of a continuous charge system shown in the figure. Impulse response of an LTI system is given. The system is excited by an input signal. For this LTI system, input is given. The correct graph for the output y of t is dash. Now tell me which option is the right answer for this question. Now audible? Okay. Now first of all understand the concept. H of t and x of t is given. So what is y of t, guys? So y of t is nothing but x of t convolution with h of t. Now h of t is nothing but two impulse function. One is present at -2 and one more is present at 2, guys. So if I am writing y of t, so it is nothing but x of t convolution with, this is 2 del t plus 2, this impulse, guys. 2 del t plus 2, and here for this impulse it is this of course 1, so plus del t minus 2, guys. Clear? So here y of t will be x of t convolution with this one, so it is x of t plus 2 convolution property, plus this is x of t minus 2. So here this x of t will shift right side by 2 unit, left side by 2 unit, and while shifting left side it is multiplied with 2 also, guys, and then addition, simply addition. So first of all x of t, it is nothing but triangular function, guys. 3 minus 1.5 t, it is a triangular function, because if we put t equal to 2 then also 0, t equal to -2 then also 0, and t equal to 0 it is 3, guys. So it is the triangular function. This x of t here I am drawing. So x of t is nothing but triangular function, guys. Correct? So it is triangular function between, correct, the triangular function between 2 and -2, correct, and amplitude is 3, guys, at t equal to 0, 3. Now this is your x of t, so this will shift right side by 2 seconds. So right side by 2 seconds means what? Between 0 and 4 with amplitude 3, guys, and left side by 2 seconds, so between -4 and 0 with amplitude 6, because multiply with 2. So in which option it is satisfying? Option A, not possible. Option B, option C, guys. Option B, option C, you can check. Both are same? No. Option B not possible, because amplitude 2 and 4. We require 3 and 6 amplitude. So here this also not possible. Yes, option D, guys. Very good. Option D is the correct answer. You people got the right answer. Nikhil and Sinchan, yes. Yes, guys, you got the correct answer. Option D is the right answer, guys. Option D. Correct? Are you getting? Right side, shift right side by 2 seconds between 0 and 4 with amplitude 3, guys. Shift left side by 2 seconds between -4 and 0 with amplitude 6, because 2 multiplied with 3 it is 6, guys. This one. Clear? And here amplitude is 3. That's why option D is the correct answer. Okay? So this is also conceptual question. Fine? Now next question. Question number 5. This is also very good question. Now using option elimination method, you can get the right answer within 10 seconds. Did not require to solve complete question, but just observing option L, just observing all the 4 options and simple concepts you can use, and you can get the correct answer. Did not require to solve complete question. Direct answer you can take by option elimination method. Find the mathematical relationship between input and output from this system. From this graph of output versus input, find the mathematical relation, and then you can get the right answer. Tell me which option should be right answer in this question. Which option should be correct answer? Sinchan that is saying option C. Option C is the right answer. Okay, any other answer? What about Nikhil? Nikhil is saying B. Yes. Now let us see who got the right answer, Sinchan or Nikhil, or both got the correct answer or wrong answer. Now you can see here, observe this graph. So for positive input, output positive, and for negative input also output positive, guys. For positive input, for positive y x of t, output positive, and for negative x of t also output positive. Output is positive, y of t positive. So in short, y of t is nothing but what? Mod x of t. Now mod x of t means what? Mod x of t means what? Magnitude of x of t. That means output should have only positive amplitude. Only positive, correct? In output you will get only positive amplitude, because modulus of x of t, that means you will get only positive amplitude. So in which option is having only positive amplitude? Negative amplitude cancel, negative amplitude cancel, this negative amplitude, negative amplitude, here also negative amplitude, this is cancel. In option B only you are getting the positive amplitude. That's why option B is the right answer. Are you getting? So here Nikhil got the correct answer. Sinchan, see, simple concept you can use, only positive amplitude, only. This is h of t only, but it is relationship between output and input given. Mod x of t, y of t equal to mod x of t, correct? Okay. Now don't worry, that's why you have to solve as maximum as number of question possible, correct? Solve maximum number of questions. For signals and system, it is a common subject between for ECE electrical and instrumentation. So you can solve all the PYQs of ECE, then electrical, then instrumentation. So I think you will get 500 different questions from all these branches, correct? Then you can go for ECE previous year question also, objective ECE electrical. I think from that also you will get the 300 to 400 questions PYQ. Okay, already we solved this question yesterday, yes or no? Already we completed this one. Now this is also very good question, guys. Convolution of x of t, this sinusoidal function with h of t, guys. So how to solve this and what is the answer? Their numerical answer type question. They are asking the value at t equal to pi, guys. Y of t equal to x of t convolution h of t, sinusoidal function between 0 and 2 pi only. Okay, and they are asking y of t at t equal to pi. Numerical answer type question. Tell me here which options should be numerical answer type question. -1. Okay, Tinjan Reddy is saying -1. Differentiation property. Yes, that also you can use. Yes, very good. Differentiation property also you can use. So here this x of t convolution with this h of t is nothing but it is u of t. So yes, differentiation property you can use. So here I told you, if out of two signal, if one signal is step function, then how to find the convolution? So simply integration of another signal. Do you remember? Simply if you integrate another signal from minus infinite to t, then you will get the convolution between two signals. So here y of t is nothing but integration 0 to t, guys, and this is for positive time. You can see here negative time it is 0, so that's why limit will be 0 to t if you put sin t, guys, correct? Sin t dt. Are you getting what I'm saying? If you put x of tau equal to sin tau, variable tau, guys, sin tau d tau, then limit will be 0 to t, because this is also causal signal. This is also only for the positive time. So here it will be y of t will be minus cos tau, limit is 0 to t. So it will be 1 minus cos tau 0 to t. Okay, wait, minus cos tau, so it is -1 minus cos t, correct? Sorry, plus cos t. Okay, sorry, my mistake. It is 1 minus 1 minus cos t. 1 minus cos t, guys. So we got y of t is equal to 1 minus cos t. Now they are asking value at t equal to pi, guys. So at t equal to pi, so if you put t is equal to pi, guys, then 1 minus cos pi. So 1 minus minus 1, it is 2, guys, correct? It is 2. So answer is 2, guys, not 1. Answer is 2. Very good, Nikhil, you got the correct answer. Answer is 2, guys. Integration, but integration from minus infinity to t, and this is also causal. So if you put x of tau equal to sine tau, then limit will be 0 to t. Okay, so be careful while solving the question. Okay, you are getting wrong answer due to these 3 reasons, guys. Remember this thing. If you are getting wrong answer, then observe, you will out of, okay, fine, 2 answer is correct, Nikhil. So basically there are 3 reasons behind getting wrong answer. Number 1, if your approach is wrong, if your concept is wrong, then definitely you will get the wrong answer. Secondly, if your approach, second reason, if your approach is correct, or if your concept is correct, formula is correct, but if you are doing the calculation mistake, then definitely you will get the wrong answer. And if your concept is also correct and you are trying to solve question in very speedy manner, okay, or you are writing solutions in haphazard manner, then also the chances of making mistake, calculation mistake, and if you are doing the calculation mistake, then also you can get the wrong answer. So always first observe you are using correct concept or approach or not. There should not be calculation mistake, and solve slowly, guys. Don't eliminate steps. Okay, first focus on accuracy rather than speed. By practicing the question, you can increase the speed, or speed will increase automatically. Fine, correct? Okay, so some questions I am giving the homework. See, this is question number 8. Now this is also very good question, so try to solve this question in homework. Okay, and this question, try this question in homework, guys. This is very good question, and if you are not getting the answer, then tell me in the next class also, and try this question in homework. This is also very good question. Just we have solved this type of question number 9, and this is also good question. Try in homework, guys. Again I am saying, already we have done, completed, this question is completed, already completed yesterday. This is also good question. I think we completed this. Try this question in homework. Okay, this is already completed, guys. Done, already completed. I think this is also done. All this question already we completed. Okay, so I am giving 4 to 5 questions in homework, and if you are not getting the answer, then tell me in the next class. This is also good question. Fine, so try this question in homework. This is also good question, guys. So I am giving 5 to 6 questions in homework. Okay, and you have to provide a valuable feedback in comment box about the teaching, about the content, and you are getting completely free of cost in English. Okay, so Nikhil and Sinchan, you can provide your feedback in the comment box. Okay, so guys, from next class I will start the new chapter, and it's a very much important, and the chapter name is continuous time Fourier series. Okay, so don't miss next class. It's a very much important. So all of you, thank you so much watching me live on Wallah English channel, and please provide your valuable feedback after completion of this session, and next part we will continue into subsequent module. Thank you, guys. Thank you so much.